Here is a question for the 10th standard CBSE mathematics on the topic polynomials. Here is the question. If the square of the difference of the zeros of the quadratic polynomial p of x is equal to x squared plus px plus 45 is equal to 144, find the value of p. Now we are given the square of the difference of the zeros, not the sum of the zeros. So if you consider alpha and beta are the zeros of this quadratic polynomial, it is alpha minus beta the whole square that is given to be 144. First we must understand this very carefully. So it is given that alpha minus beta the whole square is equal to 144, and we are given the polynomial also x squared plus px plus 45. Pause this video if you would like to give this problem a try. Let us now see the solution. It's a fairly easy question, but it involves a little bit of lateral thinking also. We will see the solution step by step. Now see, let us assume let alpha and beta be the zeros of p of x is equal to x squared plus px plus 45. Of course, we know the relationship between the sum of the zeros and the coefficients of the polynomial. We know that alpha plus beta is equal to minus b by a. So sum of the zeros, alpha plus beta is equal to minus p by 1 in this case, because the coefficient of x, we know that it is minus the coefficient of x by the coefficient of x squared. This is what is the sum of the zeros. So it is minus p by 1, and therefore it is minus p. Now, the product of the zeros, alpha beta is equal to c by a. C is the constant term by the coefficient of x squared. So 45 by 1, that is 45. Now, given that the square of the difference of the zeros is equal to 144, we can form another equation like this. Alpha minus beta the whole squared is equal to 144. Now, we need to use a little bit of an extended identity. We know a plus b the whole squared, which we learnt in 9th standard. So we will use the extended algebraic identity x alpha plus beta the whole squared is equal to alpha minus beta the whole squared plus 4 alpha beta. This is slightly requires lateral thinking here. You could form this, you could verify this actually and obtain the relationship. Now we can substitute the values here. We know alpha minus beta and alpha beta, and also alpha plus beta as well. All the three values we know. P is the only unknown variable that is there. So alpha plus beta the whole squared, alpha plus beta is equal to minus p, and hence minus p the whole squared is p squared. On the left hand side is equal to alpha minus beta the whole squared plus 4 alpha beta. So alpha minus beta the whole squared is already given in the question itself. It is equal to 144. The square of the difference of the zeros, alpha minus beta the whole squared is 144. So we substitute that value there. 144 plus 4 times alpha beta. Alpha beta is equal to 45. We already found out that product of the zeros, alpha beta is equal to 45. We substitute the value here. So here we have 144 plus 4 into 45. On simplification, we get 144 plus 180 on the right hand side. So p squared is equal to, on addition, we get 324. Now 324 is a perfect square, which gives rise to root of, that is p. So p is the square plus or minus square root of 324, which is equal to plus or minus 18. And that's the answer. P is equal to plus or minus 18. We have been asked to find the value of p. In this question, see, find the value of p. And that is the value of p. P is equal to plus or minus 18. And that's the answer. Thanks for watching.